Okay, very good. Let's get started then. So a bit late, and will have to be strict with the timing because we have a packed program in this session that is about projects that are not EOSC Future or directly connected in one of the EOSC calls, but actually contributing to the European Open Science Cloud or to the development of open data. And first speaker here is Dr. Carl Presser, the founder and managing partner of Premotech GmbH, and his background is computer science from ETH in Zurich, with specialization in information system, data management, data quality, data visualization, and data processing. He's involved in Metro Food Research Infrastructure, the president of Eurofear ASBL, and a member in different conference journals and working committees. So you keep yourself busy and even more busy by giving a speech in this session. So please, Carl.
Thank you, Per. Thanks a lot for the introduction and welcome everyone. Yes, I would like to show you the agenda and then we go to the first talk. So Metro Food RI is a new research infrastructure, and I would like to show you there the membership. We call it a membership app, but basically it's not really a membership app, changed a little bit. So what is Metro Food RI? So this research infrastructure is about metrology, which is the science of measurement in food and nutrition. So we're kind of the food research infrastructure. It's a network of labs, food labs, where they measure the foods, but also growing and farming facilities. I will show some more in here. We're clearly a distributed research infrastructure with many labs across Europe and also beyond Europe. We entered the S3 roadmap in 2016 as an emerging, and turned then into the 2018 into a project on the S3 roadmap. We just finished our preparatory phase, and in the end of March is then we go for the application for the implementation phase, and currently also applying for the ERIC status at the same time. So the physical part of Metro Food RI, as you can see, is a lot of labs, laboratory facilities over here, but you see also kind of this growing farming. So they have animal farms, fish farms, plant farms, and so on, crop farms, and so on. This is also the testing different approaches, how to farm them, and what happens then with the nutrients, with the contamination, and so on. So this is on the physical side, and important is also that we have over 200 physical facilities, and they're not all in one place, they're spread over Europe. The same on the electronic component, because all the partners have some parts there, their data stored there, their software they're using in the labs in combination with the laboratories and facilities. And there are also almost 100 electronic facilities, and very normally we have the hardware, the software, and data distributed, and have services for data processing, data analysis, and so on, as other research infrastructure as well. So this gives, all in all, almost 300 facilities, and we're first at the beginning. So we're expecting easily to go far over 500 facilities. And so we said, okay, we need this membership app, which is basically indexing what facilities that we have, what they can do, what they're for, and how they can be used in services in Metro Food. So this membership app, I show you some print screens at the starting, very easy, that you see the partners and my own institute, and the national nodes. For instance, like Italy has all the partners in Italy listed below there, and we can go then to this partner details. So on the partner details, we have the primary investigator, the main contact person. We use OpenStreetMap to put the address there, but we also have then some more physical and electronic resources we're showing. Also the managers who are responsible for a facility, because the different labs, there's different persons responsible, so we call them the resource manager. We also have the financial information there, the future plans of these facilities, and also the involved departments and institute there. So I think all this information, the research infrastructure know this, because you have to collect all this information in several projects. And so we realized, okay, instead of doing it 3 times, we put in an app and can later use then this data for our services. For the physical services, I show you a list. You see here that this is a list of physical facilities. You can add multiple. You see this is one partner, quite a big one. They have quite a lot of laboratories, mostly analytical labs, but also some others. And we're listing them, and we have kind of 4 types of facilities on the physical side. So we have reference material, which you need to calibrate the machines in the laboratory. We have classical analytical labs to measure the foods, but also this facility going in the primary production of fish or animals or plants, and then also processing and kitchen labs. These are also facilities in there. For each of these physical resource that we have there, we have a lot of information again about the people are involved. There we see also the sector in which is it working. So we see it here, the different, if it's about food safety or food quality, is it about nutrition and so on. So in which sector it's basically working. We have of course also the financial information. I deleted everything quickly to make a print screen. There's kind of go down quite long that you see what's the financial capacities and the financial needs, more important there. We have HR information for the employment there. The equipment of course is listed. So this lab has a lot of equipment, so these machines is also listed there. Plans for upgrade, and also the percentage, how much they contribute to the research infrastructure. And finally, of course, about the quality in a lab. Here is an example for the HR that we know for the staff, how much people are working there, with how much full-time equivalents, and then so on. And here is an example of the quality, the topics there placed. Then for the electronic resources, we also have some types there. We distinguish between databases, data set, hardware, and apps for the moment, and then added some more. Probably is also will grow with the time. We have info about the technical readiness level, as you're most probably aware of, from 1 to 9. What about the hosting? Where is the software hosted? Can it be self-hosted or is it remote hosted? And also the target audience is important. And of course the access and the licensing, how you can use then these facilities or the softwares basically. Here an example that's very small on my screen, sorry. Here is the some general information that we're asking about the software and the current status of the software. And here an example how it can be the accessibility, how it can be used, and also with the licensing information down there. This is of course then just for the inventory, right, what we have inside, and then we went, the other step is what services does our research infrastructure offer. So we defined a whole list of services that we're doing, and each of this facility has then to give the information to which service they contribute. So we have the listed services here, and they just have can say yes, or they need to do something to contribute, or minor or major upgrade is needed, or they don't contribute to this service, so that we know exactly what is where. And when we're coming to the implementation phase, we will then implement all the services, and we know exactly which facilities are involved there and can be used for this Metro Food services there. And the last slide is about the roles and rights, because we realize this is quite confidential information. You've seen, right, this is HR information, this is financial information there. So we elaborated quite a nice system that we're saying on institute level. The primary investigator and his deputy investigator, they have access, they can create the institute and all the facilities. And then for each of the facilities, there is a separate role that you need as a user, that you can enter there the financial information and then all the other information, and this is separated, and while others can just only see it, and the app from outside is completely closed. This is internal for the research infrastructure an app, but with the right and roles also internally we need to make sure that you don't see too much information, because that's confidential info there. And with this, I would like to thank you for your attention.
Thank you. involved for a very interesting and new area, at least for me. But it seems like a very well prepared research infrastructure and organized information about it. So we hope that we can. If we have time for a quick question, if there is anything. Yes.
You already registered a number of services in your own infrastructure. What kind of services are you think can you make available? Do you also collect data? Can you make data available or services available? And what would be the next steps so that you can make this available to users?
Yeah, if I understand what services that we mostly have, yeah. So for us, it's really for the researchers for the measurement in the labs. So for instance, they need to know the contamination in a certain food, or they need to know the nutrients, how many vitamins are in the apple and pears. And so they don't have their own labs, so they give it to the labs for measurement, getting back the data, and then they continue their study. Yeah. So mostly we're going to the food science, right? So there are a lot of university with food science. They have some labs, but these machines, they cost, single machines can go over 1 million easily euros for a machine, and the university don't have all the machines, so that's why there is also some government labs which are much bigger and have much bigger infrastructure. And so that you can better spread it all over Europe. And also, yeah, they're kind of this expensive machines, and also with the time you don't know where these labs are. There are quite a lot in Europe. Some of them are private, which we're not kind of integrating yet in the research infrastructure. Some of them are publicly governmental, this we include, and some of them are referential, European-wide even. And so with this one we collaborate, and then this for the physical one. For the electronic is also more managing the data or analyze the data in the food science area, that you know the topic, the domain, and so that we offer services there that we have central databases where we're maintaining, but also then we can do some data processing and data analysis for the researchers there.
The data which is generated by the facilities, are these going to the people who are ordering that, okay, I need someone to analyze this data, or are you collecting also data which is generated within those facilities and make this available?
Yeah, good question, because exactly. So if somebody sends a sample to the laboratory and this is analyzed and getting back the data, normally the data belongs to the orderer, right? To the ordering. Very good question. So this was a big discussion, and we went back to the labs and asked how does it work in practice? And they told us it's about 50-50. So 50% of the orderers, they say you can publish, it's fine for us, not a problem. And 50% wants to have it back, especially industry, right? So if Nestle or Unilever comes, they want their data and use it first. Sometimes they give it later, but sometimes not. And it's about 50-50. So this data that we can publish, we will publish. And we do also our own research, within the research infrastructure, and also with the university there, what they're measuring and analyzing, we will publish openly, but not all of the data, yeah.
Okay, thank you. So, good. Thank you very much.
Thank you.
Thank you. So, if you're watching the clock, we are 5 minutes late in the schedule already from the beginning. I've already scrapped my summary at the end, taking it up from there. So don't worry, we will hopefully end in time. So next time I invite Michel Granitzer, who's the chair of data science at the University of Passau, and he's the coordinator of the next generation Internet Open Web Search.eu project. His research interests are data science, applied machine learning, and information retrieval. So the talk is Open Web Search.eu towards an open web search infrastructure. Thank you.
Thank you very much for the introduction. Hello and welcome from my side. I will now present the European project, as Pierre said, that recently started, openwebsearch.eu. And in a nutshell, it is the goal that we are building an open and free index of the web. Web index is basically what drives search engines like Google. There are only a few of those, and we think it should be an open version of that can be used in different scenarios. I want briefly outline how we want to do that, some of the key points, and then also discuss or maybe hint how that could help also the European Open Science Cloud. So first, the consortium, we are 12 core partners and 2 associated partners, roughly divided into the research partners, mostly for information retrieval and artificial intelligence. We have a number of infrastructure partners. You might know them, like CERN, CSC, and IT4I, because that will be a very infrastructure heavy, or the requirements for the infrastructure are very, very big. And we have a number of NGOs that want to drive forward the topic, as well as one business partner. What is the motivation behind the project? We have 2 motivations. The first motivation is that web search per se is a critical infrastructure compared to satellite navigation. In the physical world, web search enables navigation in the virtual space, the digital space, the web. However, the problem is that there are only a few gatekeepers that provide those kind of services. You can name them, Microsoft, Google, Baidu, and Yandex. And that means that it's a kind of oligopoly, and that leads to reduced user choice. Users are locked in despite of open technologies, and we also have a bit of a concerning market behavior that you can observe. And it's doubtful whether search engine optimization for advertisement is the best way for us to find information. The other side is not about whining about those successful companies, but also that the web itself has become a tremendous and important resource for innovators and also for research. We see that in the field of AI, when new language models come that are trained on large parts of the web, and also beyond. But tapping this resource web is challenging. You need big data infrastructures, you have to have the capabilities of the person for algorithmic developments. There are legal problems associated with that, and the web is a competitive platform which is not so easy to really utilize. That is the motivation. So our goal, therefore, is to build an open web index and develop a corresponding infrastructure to do so. And open thereby means that we don't want to have a service that is used to search over that index. That is only one part, but that this web index is truly open in the sense of open data, and you could say it's fair web data. So it should be there, it should be usable for everybody. You can slice and dice the indexes you need. If you want to have all the web results for food, you should be able to download them with 1 or 2 mouse clicks, given that you have the necessary infrastructure. We have 4 objectives to reach that goal. First objective is to develop a corresponding technology stack that is more or less software development, plus algorithmic development, plus AI. So crawling content, enriching content with various semantic knowledge graphs or similar, and to provide an index. Important part is also that based on that index, you should be enabled then to describe your search engine and then download your search engine and run it similar like you run Docker images in computing to run your own search index on the topics and the content you want to do it. The second objective is to show that this has indeed added value by having different vertical search engines on top of the index. One proof of concept within the consortium will be open science search, so that we can search for different science resources, most likely focused on several disciplines. But also that we have available high quality web data collections, meaning that you can use them for other research purposes, I don't know, altmetrics or something like that. But then also to be able to research new search paradigms. Just having a ranked list of 10 results isn't necessarily for all domains the best way for searching. So to develop these search paradigms on scale is also one thing. And the second thing is to provide the data for knowledge representation models, either knowledge graphs or neural language models or whatever you want to do with web data. We need, therefore, and that's objective 3, a network of infrastructure partners. We don't believe that one infrastructure partner should do all the heavy lifting, but we have a lot of infrastructure partners across Europe, and we hope to join forces with them and have a network of those partners that maybe maintain their own specialized part of the web. So CERN could be responsible for physics, for example. And we want, that's objective 4, to develop an ecosystem around that. The key question in the project will be about is this feasible? Can we develop such an infrastructure from the algorithmic side, but also then from the coordination and governance of the independent infrastructure partners, and how much value does it add? And how do we pay for it in the end? This is a sketch to give a high-level view how that could look like. We have the web here with different topical pockets. We want to have the index creation process where there is also the room for external contributors. So if you have an enrichment algorithm for detecting hate speech, that could run over web scale data, and we could identify how much fraction of the web is really truly with hate speech or not. So there are enormous amounts, not only from the infrastructure, but also feasibility for upcoming researchers to understand information spaces better. And then we will create that index, and then you have the ability to slice and dice that index, either based on the topics or based on the enrichments or contributions, and then run your own indices, so to say, and also getting regular updates from the web through our main index into those single small indices. So you could set up a search engine for particle physics, and we would deliver updates to the index in time. You can combine that with your own hosted repository infrastructure that you don't want to make openly available, and that is how we think, how we believe that we could open up the search market as it is today. What would be the impact of such an open web index for the European Open Science Cloud? At least from my perspective, I'm an outsider to the European Open Science Cloud in that sense. But from my think, first we will have this vertical, which is a proof of concept, maybe not in the technology readiness level that is usually expected, but it is a proof of concept that we can run such a search engine, which could be integrating potential resources from the European Open Science Cloud or OpenAIR. Then web data for research, as I mentioned, web data is a research resource that can be used. So we will deliver access to pre-processed, cleaned, and hopefully also legally compliant web data. Why hopefully? It's not so sure what is legally compliant given all the regulations and the new frameworks. Then also web search as a European Science Cloud service. One could think of having curated specialized indices and search engines, and we would also hope to find infrastructure organizations that are interested in doing so, to run their own specialized search engines and maybe open that up for others to be used. And generally, I think it's important to empower users, researchers, and innovators at the scale. Important to note here, that is not written on the slide, is that we also will try to grow an ecosystem, which means we will have third-party calls or open calls to invite other people to contribute either on the technological end to the framework, or also to onboard as an infrastructure provider, to onboard with your own thematical vertical search engine or beyond. And that will also start in the upcoming month. So to conclude, we do not want with that project substitute major players. I think we can't, and therefore we need to do it differently, because the money is a lot in that project, but it's not comparable to what the major players have on a daily basis, I would say. We want to open up the search engine market and tap the web as a resource for society and research. We have the three pillars: the tech, the network of infrastructure providers, and the ecosystem. And I think there are potentially interesting services on the intersection between this project and the European Open Science Cloud. So thank you very much. My timer tells me I was briefly in 10 minutes. And so.
Very good. Well, thank you, Michael. Any questions? Yes?
Does the project already foresee support for a multilingual search? Or search over multiple languages?
Yes, we will have some, in the indexing stage we will have language detection. I think that's a standard technology. Then we will have the possibility to dissect differently. It's also one discussion we have whether, given Europe, we should split up the index in language parts, so that so France has their own French index, the Germans have their German index, and so that could be also to identify responsible groups for parts of the index and parts of the web.
Okay, thank you.
Thank you very much. Thank you very much.
Thank you very much. So, our third talk is considering data harmonization and quality information in European marine metrology, metrology research infrastructures, and we welcome Markus Konkol from the 52 Grade North Spatial Information Research GmbH. So Markus did his PhD in context of the project opening reproducible research, where he explored solutions to publish reproducible scientific results as interactive papers. So you have worked as Open Science Officer at ITC, University of Twente, and recently joined this 52 Grade North as a research software engineer. So Markus, welcome, please.
Thank you very much. So hello everyone, nice to meet you. I'm Markus. And I would like to talk a bit about a European project called MINCE, which stands for Metrology for Integrated Marine Management and Knowledge Transfer Network. MINCE is actually quite a big project. So we have 22 organizations from 10 countries. And one of these organizations is this one. It's 52 North. This is where I'm coming from. 52 North is not, as the map suggests, in the south of Germany, but rather in the west. And 52 North is a small geoinformatics company in the context of applied science. So imagine you are a researcher, you want to apply for funding, and you also have a work package on software development, but you don't have the skills to do so, you don't have the capacity. Then these researchers can contact us and we overtake this work package to do the research part, and the research engineering part. And the project has 3 integrating activities. So first of all, networking activities, which are there to foster a cultural change, a culture of cooperation between research infrastructures, but also scientific communities, industries, so it also goes beyond science, and other stakeholders as appropriate. And we are all there to develop a more efficient and attractive European research area. The second one is transnational access or virtual access activities to support scientific communities and their access to research infrastructures, and finally joint research activities to improve the quality and quantity of the integrated services. So this is basically the project in a nutshell. There's also a very nice website, but the project started in 2021. And it's, as I said, it's quite a big project, so I cannot cover all the aspects. I will focus on one specific aspect, but more on that later. So what is the main goal of the project? So MINCE will integrate key European marine metrology research infrastructures. And it's about measuring essential ocean variables. So essential ocean variables are, for example, water temperature, water color, salinity, carbon, and stuff like that. And the question is how to measure them. So we have accuracy, so which is about minimizing measurement errors, and we have completeness, which is so in this project we focus on these 2 aspects, accuracy and completeness. And completeness is about minimizing the interpolation errors. Completeness also contains, again, 2 dimensions, which is a spatial component. So an area can be covered in a complete way or incomplete way, but also regarding time. So if you have a measurement every second or every week, that's a difference. So that sounds a bit abstract, so let's make it a bit more concrete. I would like to focus a bit on the quality aspect of observations and data. So let's assume we have an ideal case. We have a coastline, and we would like to measure some essential ocean variables on this coastline with sensors. In an ideal case, we have many sensors that are very accurate, which means that we get very accurate and very good high quality data and observations. But the reality looks a bit different. So we have an accuracy-based approach, which means that we have just a few sensors, but these sensors are of high quality and provide very accurate data. The problem is a bit, since they are very cost intensive, we don't have that many of them, we have a very bad spatial and temporal coverage, so it's not complete, and so we get interpolation errors. But there's another approach, which is the completeness-based approach. And the completeness-based approach, we have low-cost sensors, which has the advantage that we can have many of them, but we don't get that accurate data. So the problem is that we get a bias. So we have high-cost sensors, low-cost sensors, and we want to integrate them. So we want to have some kind of a data fusion at the end to integrate both data sources into one infrastructure. And this is one of the main goals of this MVE project. This is how it would look like on the map. So we are currently having some kind of a accuracy-based approach where we have many high-cost sensors, but we also want to have a complete approach to cover the entire, or to cover many parts of the coastline. How do these sensors actually look like? So we have, again, these sensors that have a very high accuracy are coming from the scientific domain. They are cost intensive. Maybe you need some kind of a special education to use these sensors. There are quite strict regulations to bring these sensors in place. And on the other hand, we have these low-cost sensors which are used in citizen science projects, for example, so by citizens and also volunteers, and maybe they make some mistakes, maybe the sensors itself are not very accurate. So we have these two types. I would like to focus a bit on the quality aspect of data and individual observations. Because if we make decisions based on data and observations, then ideally we are also a bit aware of the quality of these observations, and maybe also the uncertainty. Maybe quality and uncertainty are the same, probably not. But how do we get this information about quality of an observation? So one source is, for example, test reports. So sensors are usually calibrated from time to time. And it usually has a similar process. So here I sketched a process for a sensor that measures temperature and conductivity. So the sensor comes to the labor, and they check the sensor they check the sensor as it is. So they measure some values. They have reference values, and then they check whether the deviation is within a margin, an error margin that is okay. But usually they are calibrated not only once, but a couple of times. And maybe the previous test revealed some calibration coefficients already. So they try to measure the observations with the old calibration coefficients. And then they check again, is it okay, is it not? And if it's not, then they have to calculate some new calibration coefficients. And then they check again if the error margin is fine. And this is how this calibration looks like. And this calibration report contains also quite interesting information regarding data quality and the quality of observations. Also regarding time, for example, when has such a test been done the last time? It's a bit of a difference if it was done yesterday or 1 week ago or maybe 2 years ago. So if it's 2 years ago, then the data might still be of high quality, but there is a bit of an uncertainty. There are already approaches that show how the quality of an observation looks like. So there are these quality flags, which means which has a few levels. So level 1 is, for example, pass, so the data is of good quality. Level 2 means that the data is not evaluated. Level 3 means that the data is suspect, or there's maybe something wrong with the data. And 4 means that it's not valid. And missing data is level 9. The problem with these quality flags is they are not very transparent. So what does it mean if an observation passes? And why did it pass? Why did another observation not pass? And the idea is now to have a metadata scheme that contains a set of information to assess the quality of observations and data sets. And here we have 3 components. So first of all, the sensor, which comes with accuracy and precision information that are usually provided in a sensor specification of the vendor. We have the test report again. And also we have the observation itself. And the idea is basically to have a set of information that makes it possible to calculate such a quality flag. And at the end, you might still reach just a quality flag, but you can also access all the information that led to the quality flag. So if you are not sure how this quality flag was calculated, then you can look up the information. Maybe there's a formula behind that uses these parameters. And yeah, I don't want to go into detail because I'm running a bit out of time. But yeah, the idea is basically to show all the information that I needed to assess an observation's quality. And yeah, that's MVE in a nutshell. Thank you.
Any questions? Here. Yes.
Just one very briefly. I don't know. You might know about Blue Cloud. We did a session at 11. So first, I would like you to join. Also, further discuss how you deal with the. So we talked about quality. We talked about metadata approaching the process of gathering the data to then release them. So the complete chain of fair approach to the data would be useful to understand in a concept of federated data gathering. So you deal with your own teams, sensors, the travel. So it would be good to further discuss how you manage to ensure fairness of data across the full chain.
Yeah, sure. Let's do that.
Yeah.
All right.
And maybe just as an idea, in the industry sector, there's this new standard arising for describing like sensors, machinery, and stuff like this. I believe it's called a data shell. It's an international standard. It might be good to align the data model with this one.
Yeah, good idea. Thanks.
Okay.
All right. Thank you.
We thank you. So, next talk was to be about AI for EOSC towards the scientific exchange for AI researchers in the EOSC by Alvaro Lopez Garcia, but I've been informed that he missed or the flight left without him.
Maybe would cancel.
Or cancelled flight or something, yes, but some issue with the flight. So we will jump that talk and go for next talk by Androniki Pavlidou at Inner Research Center, and welcome you.
Well,
And
thank
talk
you.
will be AI. So we stay on the theme of AI, AI-driven policy making using open scientific data. And Androniki is mathematician,
Yes,
a science and innovation manager and design engineer. It's a task-driven innovator who is passionate about technology.
of course, and
It says
startups.
here. And currently works on Intelcom. It is a Horizon 2020 project as innovation manager. Participate in EOSC Future on the Digital Innovation Hub and on OpenAI Nexus as a service portfolio manager.
And we don't have
So-
internet. Okay.
Androniki, please,
Yes.
do you find your presentation?
Give me a few
You
seconds
have
because
to
we
move
don't
forward.
have internet and my presentation is on the drive. So I don't know why we don't have internet.
What happened here now? Of course, there are troubles.
So not bad day only for flights, but also for other things.
There
Let's
is
see if it
a
works.
connection.
They don't. Can we ask them to?
Do we have anyone with a connection?
Congress,
with
Congress. Wait. Give me a
Yeah,
second.
Congress. Look, try to use that instead.
No, it's so big. No. Yes.
You have to. There was something.
Sorry, you can't.
I
Yeah.
use my hotspot if you want.
Yeah. Can you?
Oh, yeah. What happened here?
In
Hi.
case this is not working.
Thank you very much.
Okay, good. We lost internet connection here. So I guess we used that wrong, but okay, it's some stuff is internet.
So, do we have any policy makers here in the room? Anyone who is a policy maker, a funder of research? No.
Yeah, me too.
Or someone who wants to become a policy maker or a funder of research, you know? Because, you know, I'm trying to say what kind of questions do I expect now? You see. So the next session is about the Intelcom project, which is about using open science and EOSC providers. So we have a connection that might have been an anecdote years ago, but now it's reality, it's EOSC, so we can combine things together.
No. Okay, so where did we have the
presentation? Should be here on the drive. Okay, it's number 5. You can use this one. I have it as a PDF, as a
okay.
double. Okay.
And we should download it so we didn't lose it again.
Okay. So now it's everywhere. You cannot escape from this presentation anymore, you see. Okay.
Yeah.
Thank you.
Okay, good. So, please.
Yeah, thank you very much. So, what we are doing at Intelcom, today I'm going to present you the basics, okay, because I knew I had 7 minutes. So, it's AI-driven policy making using open scientific data, and more, actually. So, about the policy making, the idea is that we have the human factors and the technology, data, and science factors. I try to separate them to make sure we are all on the same page. So on the left side, you see the human factor, which is about if I am a policy maker, a research funder, somehow with all these evolutions happening around, I started maybe from here when I was young, and then things are moving and growing, and then I have to be something like that. So I have to build my knowledge, and also I have to be expert in one domain, maybe then in a second one, and maybe now in a third one, and a fourth one. And this process may continue for years, so it's not easy for policymakers now to find the information, read it, understand it, comprehend everything, and make sure they can make the right decision. So it's very complex. At the same time, we have the scientific evolution. So we have the new data sources that maybe are structured, but maybe they are not structured, unstructured. We need the scientific validity also. We need the tools to collect, to analyze, then visualize all that information. And also, we are humans. There is this human factor, again, which is about, I need to make sure I understand it easily. I need to see graphical information with graphs, with visualizations, and then I have to have a better view of the things. If I focus only on one domain, maybe I'm going to miss something else, their connections. So, and of course, I need sustainable solutions. So I need something that will be there after 1, 2, 3, 5 years for me. And we have the European also, the research and innovation activity. So it's a big deal for EU. They had spent 310 billion euros. This is for 2020. And it's a high priority. It has to do with Europe's growth, economic growth, new jobs, and of course, always societal challenges. And at the same time, we have the policy-making research and innovation, which means they have to align with the priorities that the Commission sets. They also have to follow the new trends, the new information like the Sustainable Development Goals classification. They have to make sure that the policies are open, inclusive for everyone, transparent, evidence-driven, and of course, as OECD noted here, responsive to the wide range of citizens as possible. And of course, up to date. And in all this, we have the policy cycle process. So it happens that there is not just one policy that we run for years and then we just forget it. We have to go back again. We have to set the agenda to define the problem, formulate the policy, and then make this choice, implement and evaluate. So this is an ongoing cycle. And now Intelcom comes and says, okay, now we have open science and we're going to give you a solution. The project is for 36 months. We are 13 partners. The coordinator is FECIT in Spain. And sorry for looking like this. And the objectives are, we need to understand the challenges of science, technology, and innovation policy making with co-designed framework for all the stakeholders you can see there. We also needed to create a data space of STI data sources. And here comes also EOSC, you will see later. And we needed to develop analytical tools for the analysis and visualizations of the data sources that we have. And also, we need to have extra tools for the policy models and deploy them on HPC. And at the end, come back and say, now we need to ask people on the 3 domains that we focus, health, AI, and climate change, what they think. So we need to co-develop, be open, inclusive. And what we have here, we have that when we started working on the project, we realized that we need to examine which are the research and innovation factors. How are we going to connect these factors with the policy questions that we receive? And which data sets can answer these questions? And then how can we define the indicators we are going to use in the platform? And we had a specific, for example, a question for the agenda setting. Someone will log into the system and would say, and will want to see, where should I invest next? This kind of, it's an easy question, but to answer this is very easy question. Many things should happen on Intelcomp. And then for impact evaluation, someone might come and ask a policymaker, what is the impact now of the research and innovation activities on society, on different sectors or areas, on the short, medium, and long term? So they need to see some information, and it has to be correct. And of course, how my funding and policy approach contributes to society, to SMEs, back to European Commission, back to scientific ecosystem, to EOSC. And then this is just a screenshot, a small screenshot. We had the phases of the policy making process. And on the left, you see the column of functions. Functions, there are more. They are about the research and innovation activities that we identified. And then we had to click boxes and say, for this function, this phase, this question, these indicators, here we move on. And how we connect again with EOSC. So as you see, what we are using on the STI data space of Intelcomp is the OpenAir Research Graph. So this is the main, the core provider of all the open science data sets. We will follow for sure, because once we are working with the graph, we know that we will be EOSC interoperable. We will follow the guidelines, so we are in a good position. And also we run on HPC in Barcelona, and we will use for AI B2 access. I will make you happy, you see? My colleague there. So we have many providers in one project. And for the graph, why we use the graph? Because the graph has more than 146 million metadata collection records. So we know the information is indexed there and it's cleaned. Everything is very, very nice and trustable, and it's something that we didn't have to do from scratch. We have enrichment of metadata. We have also additional things in the graph. We have APCs, we have citations, we have things that are not visible sometimes, and there are hidden values there that maybe for policymakers are very, very important. And of course, it's open, transparent, and replicable. And I will show you just two tools. Here is the overview. So at the end of this project, what you will see is the STI viewer, the STI policy participation portal, and the evaluation workpage. Right now, I will show you the STI viewer and the catalog of data sources. So the last two are for the next months, for the next phase. And you see here who is the targeted user, organization, the main functionality, and how it connects with the policy-making cycle. And if we used a tool, this is very important for the sustainability also of other projects, because we didn't say, we know everything, we start from scratch. We said, you know what, there was Data for Impact years ago, a funded European project. They had so much knowledge. Let's build on that. And this is sustainability also, and it shows that we can continue from what we had. And we also have the corpus viewer from Spain, from FECIT. FECIT is using this one with OECD. So we said, okay, it's good. Let's improve it now. Let's put it inside the platform also with data for impact. And for the catalog, this is just a screenshot of page 1. So once you visit the STI Intelcom data catalog, you will see also the data sources from many different places, like the graph. Elivec, it's HFRI, it's the Greek funder. You see semantic scholar, you see about patents, you see job portals, because we want also to make sure that we connect with society. And you see the portfolios of EU funded projects, drug bank. And the STI viewer, this is something you cannot see publicly. I mean, it's there, but you don't have credentials, so sorry about that. With the STI viewer, you can browse data sets. And I had 3-4 screenshots, but I had to take them out, so I will explain in a few seconds. So you can browse data sets, or you can search a topic. The topic is AI or health or climate change, because this is where we focus right now. And then you will see subcategories of the topic, and when you click, you see graphs. And these graphs are, for example, one, I picked it up, is this one, international collaborations by topic. So if I want to see what's happening, am I good with international collaborations as a policymaker, as a EC participant, I will go and check it out. And what is trendy also here. And another thing you can do, you see there it says portfolio requests and my portfolios. This is very, very important because it connects with the catalog. And when someone comes to the catalog and requests for a data set, then there is this slicer of information. So when you come to the catalog and you ask to process a data set, we don't say, yeah, fantastic, good, do whatever you want. We say, would you like to describe us, what do you need for which purpose and how you're gonna use it? And then you send this request, and once it's approved, we run this slice of information from the graph maybe, or the whole data set, and then you will see it also here. So what's next? I finished. Now, what's next? Please follow the Intelcomp events page and the newsletter, because we had started the Living Labs workshop. So the AI Living Lab kickoff started in Spain, in Madrid. I think it was 20 days ago. And we have more national events for policymakers and also more funders of research in Spain and Greece and France coming soon. So thank you very much. And the sustainability last, I described it in the previous slides, but I thought, okay, just you can have a look. So it makes, it shows that everything I've said, it's true. Okay. Oh, yeah.
Thank you.
So thank you very much. That's it. Any questions?
Yeah, we have a question.
You know, after that I can ask, now who wants to be a policymaker and a funder again? You want to be, thank you.
I have a question.
Oh, yeah.
And actually it's also related. Have you thought that these tools and this analysis that you are developing could be also very interesting, not only for policymakers, but also for organizations, or like it could span to other types of users?
Yes, many of these tools, not all, many of these tools will be open source available outside, not just for the consortium and not just for Intelcomp. Yes, because we already agreed with for the licensing. Yes, and it has to do with the sustainability also.
Okay.
Yeah.
Thank you again.
Thank you very much.
So then we move on to the next talk, and I ask David Raymond. And now we have to find the presentation. Skip that one, and we should go somewhere here. try this one again.
I hope the internet connection is working also. Well,
Again, it says we are offline.
you are offline.
Yeah, again, we are
Okay.
offline.
Should we try to plug it in?
No, it's just offline. So it's connected again.
It's connected. It's not simply just not fully stable.
Well, I hope. No.
Yeah, so we have it for sure.
Yes,
I
but I need
downloaded.
internet connection.
Ah, okay. Yes. It's simply not stable. We have to go through, jump a bit in the program here. As a quick recap of every presentation so far.
It's a movie.
And the one we missed.
That's what's the first time. Here.
There you go. Good.
Yeah.
Yeah.
Second. Well, at the moment,
So
I will
while
need
we are
connection to
fixing
internet,
this,
but
I
I
present
will-
David,
Yeah, everything. I have a
and
cross
he's
finger.
a library
Yeah.
and information science assistant professor at the University of Toulon. He works mainly on the use of digital methods to explore plant and academic documentation. Patent and academic documentation. Sorry. Please.
Thanks for the introduction, and I would like to thank also the organizer for allowing me to present aside a lot of very important projects. This project is a result of student activity practice in the master, as we wanted to answer a question from the presidents of the university. They asked for cartography of competencies and expertise inside the university. At this time, 2 years ago, recommendation about open science were also starting in France, and they were not mandatory, but they were starting. So we decided to tackle both problems. The first one, to accompany the community to the open science, and on the second side, try to reproduce a cartography. So that's the starting point. And I would like to thank Alaric Tabargues, who is now PhD student aside this project. So when you have to present open science to researchers and self-archiving process, mean just deposit your production on an archive, there are two ways of answers. First, disciplines that have traditionally open. So they say that's already done. Others, they are just afraid of the amount of work that should be done for them, meaning all their production have to put into the archive, and they're just afraid of it. They don't mind that there are existing processes that, the archive in France do gather many databases and self-aliments its database. And they do not know about this process. Secondly, metadata, we have shown, you show in the graph up there, that half of the production have, more than half of the production have no metadata, or very bad metadata. I saw some titles that were marked as title, abstract, as no abstract. That's missing information about the description of the production. And if this data is not present, in the indexer, they were missing. So what I call first is that when you put all your production on an archive, you are stressing your visibility. And when you put all the metadata, you are addressing your readability. And that's where comes SoVisu. We address the self-archiving process, self-diffusion, and validate information. It is integrated in the university information system when you log in the university. The whole process is governed by documentation and policymaker inside the university. Means you need the right of the president, the favor of the president to do this. And we facilitate the quality management and participate to a collaborating building process to the synthetic cartography. Data is checked by the experts themselves. I mean, when you are a contributor, you check your own data. And we make aggregation and indexation of such information. The first process is that we involve them taking in the right side. The first they had to do is to get an ORC ID, recommend for the moment, an ORC ID, and secondly, an archive ID, an ID to our archive. And that's where comes Sauviezou. The objective, I hope that's the moment. That was a crucial moment. Maybe Congress?
Yeah.
Let's try. I'm sorry. Well, I get some time in the showroom if you want a detailed presentation. I hope that's the good way to sign in.
No, it's not the problem. It's not the slides here. It's just you need to.
Network expired on May. Fine.
I think we have to. I'm sorry, but you have to skip it.
Okay, no presentation. That will be nice. Okay.
The presentation is there still.
Yes, I go back to the presentation. That's not mine. I've lost it.
There, yes.
Well, I hope so. Well, the result, you won't see the cartography. We provide lexical cartography of for each researchers. You can see the lexic that represents his production, and he can change and modify the content directly on the archive so as to fashion his lexical representation. Secondly, he can also discriminate production that he is not the expert in. I mean, if you collaborate with, I don't know, an economist, the machine will address you the hat of economist, even if you are a computer scientist, and so on. So we can discriminate what is relevant to his expert profile exactly, and this remain into the system and the indexer system to be finded again. The fact is, when we launch the system in one email, just 50% of the population came to just to check, just curiosity, I say. But a third part of them did change their profile and try to fashion it. I mean, we stress the ego. That's not factual. That's just feeling of what we saw in the university. I didn't make any enquete. You know, I don't say a survey. That was not a survey. It's just a feeling of what we saw. In the second mail, we address also the possibility for the system to make the agreed part of evaluation documents, meaning just taking what is the production, and that came to nearly 80% of the community that came into the system and check their data. So for the moment, I think that is useful inside the community. I mean, and I come here because I want to start a bottom-up process. I mean, we come from the users and we want to get them up to EOSC system and services. And it's a good way because we enter with a profile which is mastered by the users themselves. And this profile could be used to profile and get services, specific services to discipline or to lexical representation of the users. The system is open source, flexible, robust, and scalable. It's a bit tricky here. We use Docker and Elasticsearch as a background for the system. It can be easy installed into a university, and we plan to improve several features: granularity, with thesis, patents, and data, a recommender system inside the locally, and the lexical completion suggestion. I mean, very frequently it's difficult for non-library information science expert to find the right words to qualify this data, and furthermore, in several languages. That's what we are planned to stress right now. And the collaboration, I need partners to start the same process just inside another university. The criteria is simple. Here's the technical needs. And the secondly, an archive or something like that. And we could implement archived login and the same process that you didn't see, but believe me, it's nice. And we could participate very soonly in a project. And here opens something that I have, the owner of the project have to just write it. And I need just a university that would allow to make the experience of setting it into their university. 1 month left.
Okay.
So thank you. And of course, I will make the presentation with my machine aside well, during lunch, etc. I can show you many things.
Okay. Thank you very much. And sorry for not being able to do the live demo there. Any questions for David here?
Well, of course.
Well, okay, you're available.
Yeah, just a comment perhaps to the percentages of people who reacted. I work at the local Czech Technical University, and we have been also emailing people around with a request to please consider registering your ORCID ID in the system. We've seen similar response rates, match reduction rates. So I can confirm that it's difficult to steer the users.
Yes, and when I confirm, but when you show the representation of the work of a researcher to the searcher, they mind that it is not their work, and they understand also that they need to fashion it and to clean it to be seen on the, and that's the way we enter the system. I think that's why it works, because you show the researchers that even if it has published and even if it is open, it is sometimes not so good as he thinks. Thanks.
Okay, thank you.
Thank you.
So, next presentation, InterTwin. I ask Xavier Salazar. Come here, yes. So, and you can switch slides with this if you want. And so, InterTwin, extending the technical capabilities of EOSC with modeling and simulation tools, digital twin engine integrated with EOSC compute platform. So, and Xavier is Senior Strategy and Innovation Officer in the EGI Foundation with 15 years of experience in innovation, strategy support, project management and business development in both industry and public sectors. In InterTwin project, he acts as innovation manager. So please, InterTwin.
Okay, so thank you. Can you hear me well? So first of all, so thanks everyone for joining this morning, the last day after the social event. So first I wanted to start with a wake-up question. So what do you see here? Some ideas, some pictures? Somebody want to contribute? some facilities, okay, of different domains. Okay, so it's different scientific domains that are having in common that they gather and they need to process big amounts of data. Okay, so it's astrophysics, radio astronomy, high energy physics, solid Earth, and environmental sciences. And the second question, so intertwin stands for digital twins. So do you know what's a digital twin? Yes, somebody can. Yes, so it's a digital representation of a system of the world, but with that has something special, that it's fetching data real time and that it's getting updated real time over the time via, and it's getting the model updated via modeling tools, simulation, artificial intelligence. So that's why it's named like a virtual twin of the reality. Okay, so in intertwin what we want is to find the commonalities or common aspects that would enable to create a digital twin engine that we can build on top of this by using your resources. Okay, so this we are covering one of the overall objectives of the call, and so we are aiming to co-design, implement the prototype of this digital twin engine, and we will build on top of it like several digital twins to show that it works. And by doing this, we'll work on the interoperability between the different technologies, and we will try to get them integrated into the EOSC ecosystem of technologies. Okay, so we are like more than 30 partners. It's coordinated by the EGI Foundation, and noteworthy to mention, like most of the partners that are computing power providers and most of the partners providing technologies are already like EOSC partners and are already delivering to EOSC or via EOSC. Okay, and I think this is one of the big advantages that we have. And so the main specific objectives are develop the engine itself, to create the blueprint architecture that would enable as well like to broaden it, to extend EOSC capabilities, and to build all the tools and all the different aspects so that everything can work all together. And at the end of the day, so we would aim to make the realization of further digital twins across different and many other scientific domains more easy for everyone. Okay, and so how, getting a bit more into depth, but without getting too much detail. So how is it built? So it's in different layers. So on the one side we have the infrastructure. Okay, so are the computing capabilities that will be needed in order to run the different data sets, the different simulations. So, and we have a combination of cloud infrastructures, data sources, and high performance computing. We have the core modules, so encompassing all the modules that will link like the digital twin engine infrastructure with the actual digital twin, and all the simulation, data simulation, big data analytics, and all the different tooling and capabilities. And then in the upper layers, we will have like a thematic modules that will help to link with the real world and the actual digital twin itself. We will follow like a development cycle that we will manage to get a couple of iterations. So we will get the design and specifications, first release and integration, validation, and out of the first results, we will be able to extend it and to improve it. Okay, at the end of the project, we aim to have a software of in TRL07, so it's a research project. But some specific technologies, we expect to have them like on a higher level. Those that are on highest levels, we aim to onboard them as EOS resources. And as for the rest, like we are going to share them as a software research product. So we are starting at this point. So we expect to have the first architecture, the first blueprint architecture and design and specifications early next year. And during the second year of the project, we will get the first releases, and the third year, we will get the final releases. Okay, so that's an interesting moment at this point, because if you want to contribute, or if you have some ideas on how to to implement a digital twin on your domain, so it's a good time to talk to us and to sit with us. Okay, so we are collaborating already with many external initiatives. So we have a set of brother and sister projects. So it's in the bio domain, the BioDT, in the air science domain, the DTGeo, in the health domain, the eBrain Health project. And as well, we are like trying to engage with bigger initiatives like the Destination Earth, like Gaia-X and AI for Europe. And obviously, digital twin was created and was spanning from the Industry 4.0 world. And we would also like to engage with them to understand how all the commercial paradigms are also available for our scientific domains. So we have some expected exploitable results that would be like the digital twin engine, the whole framework that enables to interoperate, the toolkit, the quality framework, and overall the open source community. And well, we are working from the day zero to go and create an impact. Okay, so we would expect, or we are expecting to be able to enrich the Open Science Cloud services. This would enable opening completely new markets for them, and at the end of the day, like to contribute like in the overall broadening the R&D capabilities in Europe. So it's quite ambitious. So how are we going to contribute to EOSC? So we expect EOSC to be one of the main channels for the community and ecosystem development. So we are welcome to share with you all the results, all the progress. We expect to use computing resources. And at the end of the day, we expect to get all together, like become part of the new services. Call for action. So as I was telling before, now we are starting, we are collecting requirements, we are collecting ideas. We would like to engage with all of you. So if you have ideas, and we are welcome. And please follow us in our social media, and you can find more information in Intertwin, or just talk to me. Okay, so thanks a lot.
Okay, thank you. Any question for Xavier?
Do you have any training activities planned to spread about this community?
So we will have, so first of all, training as itself, you can only have it once you have like the first working tools and working modules. So we expect like not in the early part of the project to have. We will have activities, workshops, like not specifically hands-on, but to work on the solutions. You can follow them on the website. And then as for once we start having like the solutions, and they have enough maturity to be able to put people in a room, play with it, to make like some more dedicated training, it's some natural step to do. But it's before there will be like rather than specific trainings, workshops, like gathering of feedback, getting more like on the co-design part rather than on the training over some complete tool. But obviously at the end, yes. Yes?
Okay, thanks. Sorry, we have to cut. You can have, there is a coffee break soon.
Okay.
You can talk in Spanish.
Okay.
Yes.
Okay.
Because we now have the final presentation of this session, and I welcome Sebastian Sigloch.
Yeah, that's all right.
My pronunciation here. Sebastian is head of data and insight at Switch, which is the Swiss National Research and Education Network. Sebastian joined Switch in 2015 as Innovation and Business Development Manager. Prior to joining Switch, he worked mainly on IT projects in industry and data analysis in academia. And he has a PhD in Internet Economics and a Master of Science in Business Development.
Thank you.
Welcome. Please.
Thanks a lot. So I hope that I'm not stealing too much of your coffee break now, so I try to be as brief as possible. And I like to talk about the Connectom project. So first of all, why did we start this? And then later on I will explain what it is. So essentially, what we saw in discussions with our researchers and my students is that nobody knows what data exists, what the quality of this data is, and how it may be reused. So this was the starting point for the project. And essentially, what we set out to do together with now 10 partners in the Swiss university landscape is the following. Basically, we are harvesting the metadata from various open data sources. We are enriching them into one format. This format is called RESCs, or you can find it on rescs.org. It's essentially a subset of schema.org. What we do in these enrichments is basically a cleaning of the data, a normalizing of the data, doing the mapping, the crosswalks basically, but also enriching them with modules that we are building, such as disambiguation of author names and stuff like this. And then basically the data exists in RDF, so in a graph format. Based on this graph, we are also building an index. So we have both a graph and an index that allows to get this linked data into an API. And from there are basically different service providers, and in the future maybe also EOSC can basically take the data, take the insights, and do something with it. And in addition to the API, we also have some notebooks where we can do some calculations on this linked data that is then also available through the API. And what I will show you now is basically some of the use cases we're working on in the data enrichment, and some of the use cases we're working on in the service provider area. So basically, it all starts with the mapping of the data. This is what we call crosswalks. And essentially, what you see on the left-hand side is some of the crosswalks that we implemented. There you see that we have the data from archives, library data, data from Cordis, OpenAlex, a Swiss funding body, and a Swiss open data provider. And we map these data basically all to this RESC ontology. And to align this with what is happening at EOSC, basically my colleague Kurt, who's in the room as well, he's in the task for semantic interoperability. Right. Okay, so I start with some enrichment use cases. So what we do with a local library in Switzerland, and also together with a University of Applied Sciences, is that we first of all make archival data linked. Then what we did as a use case for a memo-base, this is a collection of cultural heritage in Switzerland, and a DASH, this is an institute for digital humanities. We did a recognition of named entities, which means we extracted information from their metadata and enrich the metadata with additional properties and something like this. And then obviously the building of the crosswalks for aggregation purposes. And then when it comes to this discovery, there are different things going on. So one is the website masirop.swiss. This is a consortia of 10 organizations working all on AI. And what they were interested in is basically to get information on research projects, all related to artificial intelligence in Switzerland, and to get the data out of the graph for this basically. Then there's a project where we are calculating so-called openness scores. Now, so on the basis of the linked data, we are then deriving things like the licenses of the data, and with this information we are then calculating an openness score that can be reused again for the service providers, but also for the public funding bodies. And then a platform we are working on is basically a discovery and insights platform for students. And there the focus is basically also on insights. So based on the linked open data graph, we are generating visualizations. So for example, the relationships between people on a given topic. What we also do is we can give, based on the index of the graph, recommendations on interesting open data or interesting publications a researcher can look at. And then what we were also building in the pilot phase and are now bringing into the next step is the use of automated summaries of abstracts and also simplifications of abstracts. So there was a use case, for example, that a second grader student can understand a complex research article with this. And then, in addition to what I showed, there are more use cases that are coming up. So what we see, for example, in the library space, they are asking for specific collection discovery platforms. We have use cases from the government side that want to enrich their open data platforms with with information from other sources using the graph, and also some use cases in the education sector. So the education sector in Switzerland aims to build precisely something like this for education data. And where do we see the overlap to other projects? So essentially, we already had some discussions with representatives of FAIRCORE for EOSC in this whole topic of metadata and crosswalk registries. And we are looking for projects that relate to all these kinds of data enrichments, the researched graphs, or potentially also federations of this infrastructure that we were building. And as you know, Switzerland cannot directly lead a project, but we can still collaborate. And that's it.
Okay, thank you very much.